Hi, in this video, I'm going to teach you how to solve trigonometric equations. So basically, there's going to be we're going to go over 4 types of trigonometric equations formatted in this video. So first type is linear trig. So that's going to be when it's 5 is equal to 12 cosine x minus 1 or 6 tan x minus 4 is equal to 0. So what you're going to want to do is you isolate the trig function. Then after this, you use the unit circle or inverse trig to get the base angles. Then you write the general solution. And it will look something like this, or it'll look something like this, or that. And after that, yeah. Now, the type 2 is going to be square trig, like sine squared of x is equal to 3 over 4, or cosine squared of 3 over x is equal to 1/2. And note that that is going to be that's a manipulated input. So for these types of problems, you want to isolate the square, and then you have 2 cases. It's very important. You need to include both of the cases when you are when you're considering the solutions. Okay, and then you solve each trig equation, and then if it's inside of k of x, then you solve for k of x, and then if the inside of k is k of x, then you solve for k of x and you divide by k, and then you keep this correctly. You have to make sure you don't mess that up. And now we have factoring and zero products, like cosine of x times cosecant of x minus 2 is equal to 0. So what you're going to want to do is state domain restrictions first and avoid undefined. So for example, you had to consider the fact for reciprocals, ask yourself, what is the denominator? And what can it not be? That's what you want to ask yourself. So now, composition with ln, an inverse trig. For example, ln tan sine -1 of 2 of x. So what you're going to want to do is you want to undo the outside function first with ln of y is equal to 0. And then you have y is equal to 1. So now let the inverse trig be part be an angle theta and use its principal range. Now solve the trig equation for theta within that range, and then you convert back to x. And then you want to check the domain of the inverse trig input plus the ln argument and any trig undefined points. So yeah, so let's start off with this. Okay, so let's start off with the first question. So let's say that we have 5 is equal to 12 times cosine of x minus 1. So what you're going to do is you want to isolate cosine of x. So we're going to get 6 is equal to 12 cosine of x, and then you're going to get cosine of x is equal to 1/2. So now you want to solve cosine of x is equal to 1/2. When does this happen? So this happens at x is equal to pi over 3, and you can imagine this on the unit circle. When is it equal to, when is the x value equal to 1/2? Well, that's right here, and that's at, that's when, oh, sorry, that's not right there. I meant to say right here. No, I said that. Pi over 3, that's the x value, so that's right here. And that's at pi over 3, 60 degrees right there. So, oops. Yeah. So, I guess we can draw that right here. Okay, wait, that looks weird. Okay, yeah. At 60 degrees. Now, yeah. And then this cosine, note that you have positive cosine in Q1 and also in Q4. So that means that think about SACT. So in Q1 everything is positive, so you have positive C, and then in Q4 you have positive C again. Yeah, great, awesome. So now you also have 5 pi over 3 as a solution. So you can write these solutions, the general solutions, if you were asked for what they would be. It would be x is equal to pi over 3 plus 2 pi k, and you usually want to say k is z, and then pi over 3 plus, 5 5 pi over 3. And remember 5 pi over 3, that's 6, that's 300 degrees. So that's like 5 pi over 3. As you can see, that's right, like 5 pi over 3 is right here. Now that's gonna be K, is gonna be on C. So awesome. Now, yeah. So after this, let's do our next problem 2. What is sine squared? Okay, square root of x is equal to 3 over 4. So now you're going to take the root. You're trying to get just like sine of x, and then you're eventually just going to get x. So that cancels out. Now you just get sine of x is going to be equal to the root of, is equal to 3 over 4 plus or minus. Now, you can rewrite this as, okay, that's equal to plus or minus root 3 over 2. And now let's talk about each of those individual cases. So positive 3 over 2 sine of x is equal to negative root 3 over 2. So now you have, for this case, we have x is going to be equal to pi over 3 plus 2 pi k. And then for this, we have x is going to equal to pi over 3. Okay, wait, for the solutions, we're gonna like do the solutions on like 0 to 2 pi. So imagining that would be just like, and we'll put the general below. Let's also write that up here too, because that's what we did. Okay. Yeah. So this is gonna be like the solutions down here. Okay, that's gonna be 2 pi over 3, and then to imagine that, that's gonna be over there, and then 2 pi over 3. And then here you have x is equal to 4 pi over 3, and also 5 pi over 3. And then like if you have it like that, like it's gonna like look like this. 4 pi over 3 is just pi over 3. 60 times 4 is 6 times 4 is just 240 degrees. 4 pi over 3. Sorry about that. 5 pi over 3. That's gonna be 60 times 5. That's gonna be 300 degrees. That's over here. 5 pi over 3 right there. So now for your general solutions, you can have x is equal to 4. Okay, what? No. That's just gonna be, now you're just gonna add like a 2 pi k to both of them. That's how you get general solutions, like basically plus 2 pi k plus 2 pi k. K is gonna be on z, and then yeah, and then x is gonna be equal to, and yeah, and we're just gonna like box all of these. I'm not gonna like redraw all of these again. That's so much work. That's x is equal to 4 pi over 3, and then 5 pi over 3 plus 2 pi k. Okay, oops, that's gonna be k plus 2 pi k, and again k is on z, and then again k is on c. So yeah, you're just gonna like have all these right here, and then that's just gonna be like that. Okay, awesome. Alright, now, okay, let's say we have, for question 3, let's say we have 6 tan of x minus 4 is equal to 0. Yeah, so you get like tan of x is equal to 4. Now, when does this happen? Oh wait, you have 6, so you have to divide by 6. Tan of x is equal to 2 over 3. And now we can do, for the general solution, we have that like x is equal to tan of negative 1, because we can just do like tan negative 1 of 2 over 3 plus pi over k. That's the solution, because like yeah, so that's gonna be the solution right there, right? See, it's awesome. Now we have, for question 4, let's say that we have this is gonna be equal to, now we're just gonna like make it, we're gonna make it like this. Now this is gonna be pi over 6, 5 pi over 6. Let me, hold on. Okay, x. Okay, pull out. Now this is gonna be, the period is 2 pi k, because this is gonna be sine of x. Yeah, and then like you can do the k is part of c. basically set that equal to theta. So in reality, we actually have that like 3. So we have that 3 of x was actually like pi over 4 plus 2 pi k. Okay, this can take so long. Pi over 4, 7 pi over 4, 3 pi over 4, 5 pi over 4 plus 2 pi k to each, where k was a part of c. So now we just want to divide everything by 3, and dividing everything by 3 means like 3 like this, and then also dividing that by 3. So now in order to do this, now we're gonna have this is like x is equal to, okay, pi over 12 plus, yeah, no, we're not doing that. Okay, whatever, I guess we will do it. 2 pi k over 3. You know what? Okay, we'll figure out how that looks like at the end. And then pi over 4 plus 2 pi over k. 2 pi over 3. And then we have 5 pi over 12 is plus 2 pi k. Okay, and then we have 7 pi over 12. Then we have 7 pi over 12 plus 2 pi k over 3. And that's all gonna be oh wait, I also forgot. Okay, pi over 4, 7 pi over 4, 5 pi over 4, 3 pi over 4. Okay, I actually don't know why I did not put that one in order. But you know what, it's okay. Wait, like actually it's completely fine. Yeah, 7 pi over 4. Yeah, that's awesome. Pi over 4. Let me just double check. Did I? Pi over 4, pi over 12, pi over 5, and then I am pretty sure. Oh yeah, wait, this was 3, but that 3 canceled out. Like, just so you know, like I was almost confused on that part too, but like it canceled out. That 3 canceled out. Okay, so like you have, this is gonna be x. Okay, now final problem. Oh wait, no, not final problem. Okay, 2 more problems. 2 more problems, guys. So, okay, we can like look, like, let's move these up here. Final push. Okay, 7 is gonna be L of n times tan of sine of, okay, tan of sine of -1 of 2 of x that's gonna be equal to 0. Now let ln of y equal to 0, so therefore we get y is equal to e to 0 of 1. And like also we know like for L of n, like it's natural log, so remember ln of x is equal to log e of x, and that ln of x is gonna equal to x. And yeah, and remember that ln of e to the x is just equal to x. Awesome. So now what do? Now let's like we have this, right? Now we have yeah. So now we have tangent of sine of -1, 2 of x is equal to 1. Now let's sine of -1 equal theta. Then we have that theta is gonna be equal, on negative pi over 2, pi over 2. And Therefore, sine of theta is equal to 2 of x. Well, it's just like rewriting that part. Now we're gonna solve tan of theta is equal to 1 in the arc sine of range. Now, what is the arc sine of x range? Is gonna be negative pi over 2 pi over 2 equals 1. This is at theta is equal to pi over 4 plus pi over k. That's the period. Yeah, but only one solution in this range, so therefore we get theta is going to be equal to pi over 4. Now we're at the convert back step, therefore we get sine theta is equal to 2 over x. Therefore we get sine of pi over 4 is equal to 2 over x. Therefore we get root 2 over 2 is equal to 2 of x. Therefore we get x is equal to root 2 over 4. Now we can do a domain check. So we need sine negative 1 of 2x to be defined. So we get 2 of x less than or equal to 1 becomes x less than or equal to 1/2, and that's true. And now, now after this we need tangent of sine of negative 1 of 2 of x greater than 0 for the ln argument, and then it's greater than 0, it equals 1, so it's okay. So that means that this is the answer. Hooray. Now we just have one more problem. Oh my goodness. Tan 2 of x is equal to 1. So that means tangent of theta, we're going to let 2 of x equal to theta. So now we're going to say like tangent of theta is equal to 1. Theta is going to equal to pi over 4 plus pi over k. General tan x solution is right here. Should kind of just know this already. Pi over k. Therefore, we get 2 of x is equal to pi over 4 plus pi k. So now we want to divide by 2 to just get like pi over 2k, where k is on c. So that's our solution. Hooray. And we're literally done.